2024 A-Level Combined Mathematics Paper 1 Part A question number 3. This is the Argand diagram question. The question says, shade in an Argand diagram the region consisting of points that represent the complex number z, satisfying the inequalities first of modulus of z minus 2y being less than or equal to 2, and second, principal argument value capital ARG of z plus 2 root 3 being in between 0 and pi by 6 radians inclusive on both sides, inclusive of 0 and inclusive of pi by 6. And then given this, when we draw the shaded region, it then says find the greatest value of modulus of z for the complex number z represented by the points in this shaded region. So first we need to mark out the shaded region, and then looking at the shaded region we will have to figure out what the point representing the maximum value of modulus of z is in this shaded region. Now to start off with the shaded region, what we need to do is to consider the two inequalities that we have here, which is this inequality and this inequality. Considering the first one says the modulus of z minus 2y must be less than or equal to 2. Now considering this format, the modulus of z means the distance of the z from the origin, and the modulus of z minus 2i, or in general the modulus of z minus some initial complex number, let's say z0, is representative of the distance of the complex number z from an initial complex number z0. So due to this, since we have that format here, what modulus of z minus 2i is representing is the distance of the complex number z from the point 2i, or rather I should say 0 plus 2i in the Argand diagram. So due to this, what we need is all of the points that have distances of their point z from the point 2i which are less than or equal to 2. Now in the Argand diagram we are going to be representing this with a circle like this. So this circle is representing all of the points z that have a distance of exactly 2 from the point 2i, where 2i is the center of the circle. Now due to this, if we have distances less than or equal to 2, it means that all the points we're considering are the points on the circle and inside of the circle. So therefore our shaded region must consist only of points that are either on or inside the circle. Now considering our second condition, the second condition says that the Argand value of z plus 2 root 3 must be in between 0 and pi by 6. Now in this setup, we have Argand of z plus 2 root 3. In general, if you have the Argand of z minus some complex number z0, what this is representative of is the Argand value or the angle in the anticlockwise direction from the positive real axis of the point z relative to the point z0. Now in this case, since we don't have a minus here and instead we have a plus here, what we need to do is to introduce a minus by writing plus as minus times minus, and therefore we could write this as the principal Argand value capital ARG of z minus negative 2 root 3. Now if we write it like that, if we write it as ARG of z minus negative 2 root 3 from our format, it is clear that what we're interested in here is the angle in the anticlockwise direction from the real axis direction of the complex number z from the complex number negative 2 root 3. So basically on our complex plot here, our Argand diagram, we need to find the complex number negative 2 root 3, and then relative to that we're going to consider all of the complex numbers z and find the angles relative to that, and then see if the angle is in between 0 and pi by 6. If it is in between those two angles, then it is in our shaded region. Now considering this, what we need to do is to draw a line that has angle 0 relative to the real axis and another line that has angle of pi by 6 relative to the real axis, and consider all of the points in between those two lines, since those points would be the points represented by arg of z plus 2 root 3, or rather z minus negative 2 root 3 being in between 0 and pi by 6. Now considering the point negative 2 root 3, it's right here, I've marked it out, and considering the Argand of z being equal to 0, or rather z plus 2 root 3 being equal to 0 here, that would just be a flat line along the real axis going from the point negative 2 root 3 in the rightward direction. Now considering the other one, Argand of z plus 2 root 3 being equal to pi by 6, that would be a line with an angle of pi by 6 in the anticlockwise direction from the real axis, starting from the point negative 2 root 3 and going upward. Now considering this point, since the length here is 2 root 3, since we are at negative 2 root 3 and the length here is 2, we know if we have the 60 90 30 triangle like this, where we have 30 degrees here, 60 degrees here, and 90 degrees here, if this thing is root 3, this would be 1. If this is 2 root 3, this would be 2. And due to that, we can say, since the length here is 2 and the length here is 2 root 3, this line that we're going to draw, which is an angle of pi by 6 going through the point negative 2 root 3, is also going to pass through the point 2y here, which is the center of the circle corresponding to this inequality. Now that needs to be known by you, and you need to see that that's going to happen, and you need to draw the diagram correctly. If you don't see that and you incorrectly draw the diagram by just assuming that it's going in a random direction like this, you would get the question wrong. So instead, we need to draw the line corresponding to argand of z plus 2 root 3 being equal to pi by 6 as going through the point 2y. Now that we've done this, we can mark down this angle here as being equal to pi by 6. Now, the upper line here is representing the upper bound, and the lower line here, which you can't see, which is going along the real axis, is representing the lower bound. What we want is all of the values of z that are in between those two, and also the values of z that are inside of the circle. Now, due to this, the overall values of z represented by these two inequalities happening at the same time is going to be all of these values of z right here that have an angle in between pi by 6 and 0 and are inside of the circle. So therefore, what we're representing is all of the complex numbers z that are in this little region that we have here. All of this stuff here is all of the complex numbers represented by modulus of z minus 2y being less than or equal to 2, which is going to be the circle, and argand, capital ARG, of z plus 2 root 3 being in between 0 and pi by 6, which is these two lines right here. So now, these are all of the points that we want. For the next part, we need to find the greatest value of modulus of z for the complex number z represented by the points in the shaded region. Now, considering the shaded region, modulus of z is just the distance of the complex number z from the origin. So considering the origin here, I'm going to mark it as O here. I'm going to mark this point right here, the origin, as O here. And considering the origin and all of the other points, we can see this point right here shows the greatest distance from the origin. If we consider this point is closer than that point, this point right here is representing the point that has the greatest distance from the origin that is still inside of the shaded region. Due to that, if I label this point, let's say A, maybe we label some of the other important points. We could label the center of the circle B, and this is C just for clarity. If we consider the point A is the point that has greatest distance from the origin, and due to that, the maximum value or greatest value of modulus z for the complex number z represented by the shaded region is going to be OA, the distance from the origin to the point A. Now, due to that, if we go down here, we can write the greatest value of modulus of z represented is equal to the distance that we want, which is OA, since the greatest z that is represented in the modulus of z here is the point A. Now, considering this point, what we need to do is to find the distance from the origin to that point. So we can draw the line like this. This length of this line right here is the length that we want to find. I can label it with, let's say, I'll label it with a different color for now just for clarity, so that you can see the line easily. What we want to do is to find the length of this line right here. Now, considering this line, in order to find the length of this line, we can use some geometrical facts that we know. Now, considering this circle here, we can see BA and BO, or OB rather, are both radii of the same circle and both have length 2. And due to this, the angle here and the angle here are both equal. They are both equal to the same exact value. Now, considering the rest of the geometry here, we can see the angle at this point right here is pi by 3, since the angle here is pi by 6 and the angle here is 90 degrees. So due to this, if I label this 90 degrees, the angle here, if I label with an arrow or something, is going to be equal to pi by 3. Now, due to this, the total angle here is going to be equal to 2 pi by 3, since this is a straight line, and due to that, the total angle must be equal to pi radians, so 180 degrees. So due to that, I can label this angle here. This angle, if I just draw a line outward like this, the angle here is 2 pi by 3. Now, due to this, if this angle and this angle are both equal to each other, then let's say this angle is theta. Theta plus 2 pi by 3 must be equal to the total internal angles in the triangle, which is pi, and therefore 2 theta plus 2 pi by 3 is equal to pi, and subtracting pi by 2 pi by 3 from both sides, we can see we're going to get pi by 3 on the right side, meaning that 2 theta is equal to pi by 3, and therefore theta is equal to pi by 6. Now due to this, we can say the angles here are both pi by 6. Now we don't really need to show this working out, we can just write the answer. So we can write that the angle here, this angle, is pi by 6. Now considering this, if we just draw the 90 degrees here, the perpendicular of B to OA, we can see the length of the hypotenuse here is 2, the length of the hypotenuse here is 2, since that's the radius. And here we can see if this angle is pi by 6 and this length is 2, then the length that we want here is 2 cosine pi by 6, and the length here is also going to be 2 cosine pi by 6. Now due to this, the total length that we want is going to be equal to 2 times 2 cosine pi by 6. Now considering that cosine of pi by 6 is equal to root 3 over 2, and therefore we have 2 times root 3 over 2. Cancelling out one of these, we can see our answer is going to be equal to 2 root 3. And therefore, the maximum value of modulus of Z, or the maximum distance of a complex number Z inside of the shaded region from the origin here, is going to be equal to 2 root 3. And therefore, our final answer is going to be 2 root 3. Now in this case, I've actually made the diagram quite ugly because I've drawn a lot of stuff here. I can erase some of these extra lines and make it nice, and I highly recommend that you yourself also make your diagram much more readable than this. Ideally you would want to make it a little bit bigger, but if you're drawing this in pencil, it won't be as cluttered as what I've done here with my digital pen. So anyway, moving on, if we finally discuss the marks order for this question, in this question, when you draw the circle like this, you get 5 marks, and then when you draw the point negative 2 root 3 like this, and the line that is an angle of pi by 6 like this in the anticlockwise direction from the real axis like this, you get another 5 marks for the point and the line and the angle, of course. So you get 5 marks for that. And then for the shaded region here, you get another 5 marks, provided of course you shaded correctly. If you correctly shaded the region that is enclosed by these points right here, you get another 5 marks for that diagram. Now after this, for the second part of the question, when you write that the greatest value of modulus of Z is represented by OA length, when you identify that the point A is the point that has the maximum distance from the origin, then you say that it's going to be equal to OA, you get 5 marks for identifying that. And then when you identify the correct formula for that based on the trigonometric information that we have in this diagram, and then you write the final answer of 2 root 3, that gets you a final 5 marks. So those are all 25 marks awarded for this question, and that is going to be end of this video. So I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching, and goodbye.